So it looks like we've given the usual Berkeley time. I'd like to welcome everyone here. My name is Andrew Aquila. I'm the president of the Students Society for AS&T, or Applied Science Technology. It's my privilege to introduce our speaker today, Professor Shank. He is actually a Berkeley alumni. He got his bachelor's here in 1965 and followed by his master's and even his PhD in Berkeley in 1969, which is a pretty impressive 4-year stint to get a PhD. Following this, he had 20 very successful years at the famous Bell Laboratory, where he worked in optical communications, fiber optics, lasers, ultra-fast science. And following this 20 years, he was offered a position as the lab director of Lawrence Berkeley National Lab, which he took in 1986 and kept for 15 years in 2004. And now he's also a professor here in actually 3 departments in physics, chemistry, and electrical engineering, EECS. So he'll be talking about passion, careers, and opportunities in science. So if you please help me welcome Professor Shank.
Well, I thank you for the opportunity to speak with you this morning. The topic of my talk is going to be about careers, seizing opportunities, and pursuing passion. And in preparing this discussion, I asked myself, is there anything that you all can get from some old fart who is going to ramble on about his past? And I thought about that, and I'm going to try to make this talk relevant. The world's changed really significantly from when I was a student, a graduate student, and pursuing career opportunities. But the specifics are not really important in the end. And some principles emerge that I think are the most important. And as we go through this, I'm going to try to give you some examples and then try to draw some principles that I hope that will be useful for you. I want to finish by talking about what I think are some really interesting challenges and opportunities in the future that will really change, I believe, applied science, technology, and engineering as we go into the rest of this century. First, I'd like to talk a little bit about my career. It was a different time. The opportunities exceeded those that are available today. It's always terrible to listen to someone. I hated listening to my father tell me about the golden age. And yes, I'm here telling you about the golden age of science and technology. Bell Laboratories was at its peak. The halo effect of inventing the transistor persuaded a lot of companies that, you know, we really ought to invest in research. And there were many companies that had very vital research opportunities. During summers as an undergraduate, I'd had jobs at Motorola Semiconductor, IBM, and Hewlett-Packard. So I had a good idea of what industrial life might be like. And it was really a time where people thought that anything was possible. I think that I, like many graduate students, sort of found an area that I was generally interested in, but it didn't really excite me. It was something that I did, I enjoyed, but it was during a summer job at HP where I fell in love with lasers and optics. And lasers had just been invented, optical lasers, and at HP I worked on some of the very first light-emitting diodes that were not quite lasers, but very interesting problems in semiconductors. And I decided I really found what I had wanted to do. And so when I graduated from Berkeley and returned to graduate school, I really had a good notion of what it was that really turned me on. And I very much enjoyed graduate school, and I went to Bell Labs in 1969. And there I was given an opportunity that there are a few such opportunities like this, but they're very rare. And the opportunity was I was given a lab and told to fill it. It was empty. Had a few benches, that was about it. And the question that was pretty daunting was, well, what to do? You know, I think one of the things I was warned to do is that don't do your PhD thesis over and over again. It really is time to start something new. And it was this opportunity that really taught me something about people and about what it is that is going to make a successful career and what it is that really inspires people. And it's clear that an empty room is not for everyone. One of my colleagues, a gold medal winner here at Berkeley, just a brilliant guy, went to Bell Labs, saw the empty room, and shortly after left. He says the empty room drove him crazy. If you gave him a problem, he could solve it. He was as good at solving a problem as anybody in the world, but he just didn't like the idea of having to pose the problem. And I think that as you look at the kind of person you are, you will find the kind of things that really turn you on. And first, do you want to pursue discovery-oriented science, where you want to go out and probe the dimensions of the unknown and really get a kick out of learning very new things? Or do you want to grab a problem and use your creativity and solve that problem and really make something that works, that's tangible? Actually, both of those things were enormously appealing for me, and I really didn't quite know what to do in this blank laboratory. And you have to think about it, you know, project back in time. What was it like in 1969? There was no optical fiber. The idea of optical communications was simply a very primitive notion. People had envisioned things like gas lenses, which would contain a multiply refocused and re-imaged laser beam, but really no real concept of whether optics actually would ever be used for communication. Now, of course, the imagination was that having an optical carrier would give you enormous potential bandwidth, but optics were lossy. How could you ever do anything with that? And so when I thought about what I wanted to do, I knew that somewhere out there was an attractant. The attractant was I was working for AT&T Bell Laboratories, and they were interested in communication, and semiconductor lasers were just moving into being real devices, but no one knew how we were ever going to use them. And they were uncontrollable and not really very good sources of light. So to me, I recognized that what I needed to do was to work on something that I was really excited about. And for me, passion rules every time. And so during my first few years at Bell Laboratories, I worked with Hervé Kogelneck and invented something called a distributed feedback laser, which ultimately found its way into many optical communication systems. It was a way of introducing a stimulated emission in a periodic structure, and it really made a significant difference in being able to control the frequency of at that time, uncontrollable diode lasers. But at the same time, I recognized the importance of short pulse lasers to gain a deep understanding of kinetic processes in physics, chemistry, engineering, biology. And I pursued that road as well. And after about 3 years, at Bell Labs, someone came up to me and they said, look, you're at a crossroads. You can continue the science that you're doing and have a nice quiet life off in the corner, or you can work on problems important to the business, and you can have a really successful, exciting career here at Bell Labs. You might even be promoted into some management position. There was no right answer to that, and what I'm, in my talk today, trying to communicate is that in any of these things, there's no right answer. But for me, the answer was pretty obvious. What was important to me was passion, and passion ruled again. And I said, you know, I'm going to work on my science, and I'm not going to worry about anything else. It's what I'm excited to do. That's why I'm here, and that's what I'm going to do. I really don't care if I ever get promoted to any different position. I'm happy with what I'm doing. And for me, that was the right choice. Interesting thing was 3 years later, the people who were giving me these opportunities ended up working for me. So it was a strange outcome. But making the right choices is the most important thing you can do in a career. And I think that you can pursue an opportunity and you can look at it that way, but you've got to sustain yourself in a life of careers. And that's why it's so important that your interest and your passion have to be a very important piece of what it is that you can do. So identifying those kinds of opportunities that you can pursue with the passion, for me, is really, really very important. Now, I think it's instructive to look at other careers. I'm not comparing myself to this person, but I think he's an interesting example of a person, and that is Albert Einstein. And he was a good student in grammar school, but by the time he became a teenager and a college student, he was rebellious. He rebelled against rote learning. He did rather poorly in college, and he couldn't find a job when he got out of college. His professors gave him very poor recommendations. And so a friend found him a position as a patent examiner. And he was in the electromagnetic devices division of the German patent office. And he corrected errors in patents. He deeply understood these things, and so he was able to correct errors and really understand what was being proposed. However, his supervisors considered him an underperformer. But on the side, he was working on the theory of relativity and a few other things. He was denied promotion as a patent examiner because, quote, he lacked an understanding of electromagnetic machines, which is pretty astounding. But in his spare time, he chose really important problems that had a profound impact. In 1 year in 1905, while doing his job as a patent examiner, he solved 4 of the most important problems in physics, 4 incredible papers. The first was the photoelectric effect, in which he ultimately got a Nobel Prize. The second, he understood the mechanics and the deep understanding of Brownian motion. He wrote a paper on special relativity, and he wrote a paper on the equivalence of matter and energy. Now, Einstein didn't work on everything. He could have written papers on how to make a better electromagnet. He could have done a lot of things. But Einstein had a set of burning issues that were his passion, and didn't care where it was going to be, he was going to work on those things. And he made choices. And he asked very important questions. And I think one of the most important questions in selecting a problem to work on is, what if? What if it actually works? What will be the impact? And so Einstein pursued problems that both excited him and were within his skill level. Well, you know, it's pretty hard to measure his skill level, but I think for most mortal people, pursuing problems that both excite you and that are matched to the skills, and you'll recognize your own skill set. And the people who have had the most successful careers have figured out what they're good at and what they're excited about and put those two together. Over time, I found that I was far more excited about discovery-oriented science than anything else. And in 1989, when I had an opportunity to come to Berkeley and join the Lawrence Berkeley National Laboratory as the director, it was one of those institutions which had a very exciting past and really was focused on discovery-oriented science. The most exciting, important problems that were happening in the world at the time. And I became very excited about the lab and about the problems, the big problems facing the country, and how important a laboratory like the one up in the hill could contribute, and it is continuing to contribute today, in many ways even more relevantly today. So what does this all mean for all of you? I said I was going to draw some principles. One is, don't follow the money. Follow your passion. Second, choose problems that will work on problems that will have an impact. Ask the what if question. If it actually works, how will the world change? How will you have changed the field, or how will you have made a difference? And finally, every time you pick a problem, you have to realize that you're betting your career on it. And as I look back, there aren't that many years in a career, and every time you make that bet, it's really worthwhile thinking about, was that the right thing to work on? Was it something that really got your whole body moving, something you could work on day and night? So as we move on here, the question comes is, well, maybe I want to follow the money. Where is the money? Where are the opportunities? Are there opportunities out there that where there are potential exciting science and problems to be working on that would be of interest possibly to me? And so I've made a list of 6 things that I think are going to be a part of our future and where there are going to be opportunities. The first one is the word of the day, and that is energy. Now I must tell you that during the time I was a lab director, the Deputy Secretary of Energy and I got into quite a discussion. The Department of Energy had what they called, their fundamental science was called energy science. And they wanted to change that Office of Energy Science just to the Office of Science. And I said, no, energy is such a compelling problem that you shouldn't change it, you should leave it at the Office of Energy Science. Well, of course, they didn't listen to me, and they changed it to the Office of Science. Today, energy has one of the most important problems facing the nation. And there's a time for a great deal of creativity and opportunity. And I look at the new BP arrangement that's being made with the campus and the lab, and I look at many, many opportunities there to build new careers. But when you sign on for something like energy, sometimes what happens is that it becomes a fad and it goes out of favor. Now, the Lawrence Berkeley National Lab in the 1980s, under Jimmy Carter, we endured the 1974 energy crisis, and energy became a word, enormous amount of funding. In 2 years, all that funding was gone, and we were back to normal again. I really think the energy problem has gotten to the point, combined with other problems, that is going to stick with us. It's going to be a problem that really is something we're going to have to deal with for all of our lives. The second area is life sciences, in particular the interface with nanosciences, and the new understanding that's taking place in life sciences is amazing. Craig Venter, who was one of the major contributors to the Human Genome Project, took his yacht and sailed it around the world for a year, taking samples from the ocean and then doing an analysis of the DNA from those samples, and found that we only know about a few percent of the world's species. Within the ocean, there are so many different organisms that we cannot culture. We have no idea that are even there. Even in places like the Sargasso Sea, which were thought to be nearly lifeless, are teeming with life. And this rich array of DNA is really opening up our eyes to a huge range of different kind of organisms that may ultimately have DNA that will be important for other uses. You would have thought that taking a barrel of water anywhere in the world with a yacht and taking would be something that no one would object to. But the worry was in many countries around the world that he was taking their DNA from the ocean before they did, and the government took his boat and held it until he came to an agreement with them about what he was going to do with the bucket of water he took from French Polynesia. So it's not an easy thing to do, but really going to open up, I believe, a new deep understanding in biology. Third area is synthetic biology. Jay Kiesling here is really on the leading edge of that. It's the idea of really constructing organisms for a particular task. Fourth area is ultra-fast X-ray science. The new facility that's being built at Stanford, the LCLS, a new X-ray laser facility being built in Europe, and then there's one little bit longer, lower energy machine that's being built in Trieste, Italy. All are going to open up really new opportunities in exploring dynamic problems with X-rays. I think that climate change is something, many people think that all the science is done there. I do not believe that. I believe there's a rich field for gaining a deep understanding of our climate. I was really shocked to see the recent work that was published from scientists at Livermore National Lab, where they showed that by changing the albedo of the Earth, by cutting down the forests in high altitudes or high latitudes, that you would in fact cool the Earth by 10 degrees. And this kind of understanding what new things are going to pop up really says that this is really a very open field, and one that I think is going to require a great deal of study as we encounter climate change and try to figure out how we deal with it. And finally, modeling, simulation, and computing are all areas which I think are bound to grow in sophistication and impact. And I think that modern designs really now depend on computers. We've already seen jet aircraft that have been designed only with computers. And that is definitely going to be a very important piece of the future. So what are the challenges that I see out there for people in technology and science? And since today is tax day, for all of those who are doing your tax forms, it was a shock for me to read in Friedman's The World is Flat, that by the end of this decade, 50% of the American tax forms for American income tax are going to be prepared in India. We're seeing a commoditization of technology that is pursuing, technology is being seen around the world. We're seeing 50% of the world's manufacturing is now in China. And I ask the question, why not the rest? We're now seeing companies moving development, research, creative jobs, and to low labor price areas of the world. And these are all things that are going to happen. I think that there's very little that we can do about this. And for some people, it used to be that if you graduated with a bachelor's degree in engineering, that you could, in fact, pursue a career in manufacturing in the United States. I think those kinds of jobs are going to be lost. I don't know how many jobs like that are going to be lost, but there will be implications both for the students and ultimately for the faculty. And for those of you who are pursuing academic careers, I think it's worthwhile to think about this. This is a world trend that is ultimately going to have an impact on universities and faculties. And we have to come to the realization that about any skill that can be learned around the world and whose input can be set electronically or even not, if you have a cheap labor for manufacturing, will have a world price. And that's going to have an impact, I think, in succeeding generations of people who pursue studies in technology. This problem is way too big for us to solve here today, and I don't think anybody has a solution. But the problem will have an enormous impact on everybody in this room. And I think that one of the things that's absent for the country, even us at universities, is a strategy. We haven't really thought about what this means. And I'm going to suggest some possible strategies for this problem, but I in no way think that my suggestions are going to be complete. First, I think that everybody should realize that a technical education alone is not enough. We are going to have something in addition to just knowing and understand the technology. In many cases, it's going to be very important to have that technical education, but that by itself is not enough. For the United States as a country, and for those of us who are looking at opportunities, we need to take advantages of the U.S. culture that provide us with an advantage. And there are three areas that I see. One is entrepreneurial. I think that entrepreneurial activities will continue to thrive. We're in an environment where capital for the formation of businesses is available, and we're going to depend a great deal on entrepreneurial organization for the future of the country and future for opportunity for technologists. Business formation is going to be important. And I think that there are national needs that are going to require technologists that are going to be important that they be citizens or residents of the U.S. So those areas I think that remain very important opportunities. I encourage anybody that is going to be in a technology area to learn something about business. If you stay in the academic world, you're going to want to know how to couple to businesses. If you decide someday to start your own business or something of that sort, you need to know it. If you go work for a company in which business people are in charge, you are in a much better position if you understand something about business. I think you need to be prepared for change, and there's going to be a lot of churn. I mean, it's shocking to me that my career will have essentially involved 2 jobs, one at Bell Labs for 20 years and another one at the University of California, and that's not likely to be the pattern as we move into the future. So change will be very important. I think that learning to work collaboratively is really going to be a key to working with projects that may be in several different nations. My brother, who is an electronic engineer, is working on a project now which is part being done in Israel, part being done in the Soviet Union, I mean in Russia, and part being done in Japan. And the ability to work in that kind of a world is very, very important. And finally, I think that we have been very comfortable in being knowledgeable about our own culture. But I think today we've got to learn a lot more about other people's cultures. And I think this is going to be a really important thing for success. We're going to interact far more with the world. Our ownership of technological lead is not going to be what it once was. There are many technologies and new ideas and things that are happening around the world that are going to really be important for us. And I think as you travel around the world and you see things, you're going to be astounded by the differences in cultures. And when you see those differences, each culture has some advantages and some disadvantages. And I am not judgmental about this is a successful culture, that's an unsuccessful culture. I think that's not a good way to go about it. I think you need to look for the best in all the cultures around the world to ultimately to be competitive. I'm going to tell you a little story about a talk that I gave at the University of Tokyo. And this is not to say anything deprecative or denigrate brilliant Japanese scientists and their education system, but more to highlight a difference in cultures. I have a friend who was a former postdoc of mine, who was a professor at the University of Tokyo, and 10 or 15 years after he left working for me, he invited me to the University of Tokyo to give a talk. And I gave a talk on the latest interesting thing to me in ultra-fast processes into a room like this that was just packed. And after giving the talk, I asked, are there any questions? Not a single question. And so I made the assumption that there were no inquiring minds. Wrong. After I was done with the talk, I was surrounded by students. A bigger shock to me was that there were several students there that had a copy of a paper I'd written 15 years earlier who wanted me to sign it with my autograph, the first time I've ever been a science rock star. And I was really rather shocked by that. But when I got a chance to talk to the students one-on-one, these were very good students. And you shouldn't use the criteria of interaction that you might use in one country to have the same expectations in another. And it was an important lesson for me to learn about appreciating cultural differences and how one interacts with different cultures. And it's an important thing that you take that and understand what it means. There are some times when you are provided opportunities that you really don't know how to deal with. And one happened to me just a few years ago. Again, another one of my postdocs is a scientist in Brazil, and he achieved the distinction of being a head of their the equivalent National Science Foundation. And Brazil was having a meeting with the United States in Washington, D.C., and I received a letter from the Brazilian government to go and give a talk, and the topic of my talk was, what is wrong with Brazilian science? And it's hard to be popular to give a talk, and so I changed the title of the talk and talked about something else, about how Brazilian science needed to be supported and where it was making an impact and where it could make a bigger impact. But if I took that literally, how it was translated, I could have given a very offensive talk. And it's because I've traveled extensively in Brazil and sort of knew how questions were asked and how Portuguese gets translated that I was able to save myself embarrassment. These kinds of things are going to be very, very, very important as you begin to interact with different cultures around the world and realize that the United States is no longer going to be this island by itself, but is going to be part of a very competitive sea of very talented people all around the world, and we need to be prepared for that change. Thank you very much.
So now let's open the floor to questions. Any questions?
So going back to the beginning of the talk, you talked about the importance. I think I'm all right.
Oh, it's for the taping.
So going back to the beginning of the talk, you talked about the importance of following one's passion, and then a little bit later about that you're betting your career on your choices and not following fads. Can you give any advice as to how someone who's a grad student or a postdoc determines what direction to go, what passion to follow maybe?
Well, I think that for me, and everybody's going to be different, but I think that explore enough different places, look at enough different holes, read enough about different fields to find something that's going to excite you. And it may be that you get excited about something here, and in a few years you get excited about a new thing. But it's really got to be something that drives you and drives what it is that you want to do with your life. But if you see yourself going in a direction which doesn't make you excited to get up in the morning and go out and tackle the problem, it's time to try something new. But there are many, many, many opportunities here at Berkeley. You're lucky to be in a place with different seminars, different things to be learned. Put yourself in different environments and try to at least sample as much as you can. And then find those things that turn you on.
Any others?
You're probably sort of uniquely qualified to answer this, but what's your take on the interaction between government and like companies and universities and research? I think there's been a lot of debate lately with the BP proposal and how having a say in university matters. I think you could probably give some thoughts on something like that.
Well, I've had a fair amount of experience in that matter. I've even testified to Congress on the relationship between government and industry, and there was a period of time this was strongly encouraged at national laboratories, and I said, you know, the real problem, many people say, well, this is idiotic. National laboratories, universities don't have anything to offer industry because they have no discipline, they don't produce things on time. Well, that turned out to be wrong, and I knew it was wrong. I said the real problem is fear of success. What's going to happen if you're successful? How do you handle success? Think about it now. And some things did happen to be very successful, and we had a very difficult time as a country, began to call this corporate welfare. I don't have an answer for that, but I look at the opportunity to take people who really know about a problem, particularly for those of us in applied science and technology, where you get a chance to get really an opportunity to get exposed to that problem, that there's an enormous benefit from that. And Dave Atwood, sitting here, Professor Atwood, was really at the leading edge of a tremendous collaboration in trying to build photolithography capability for the semiconductor industry. We could have pursued that with the same amount of government money and never made the impact that Dave and his colleagues did by working with Intel and IBM and several other companies. We also did better science. We got opportunities, we got funding, and many of the students went on and worked for these different places. So it was an enormous big win. I think that some of the concern about the BP issue is, will this make an impact on the academic environment? Will it make a difference in students being able to get their degrees? Will there be conflicts over intellectual property? How are you going to make this work? I think those issues are largely understood with this interaction. This, Dave, was it $250 million roughly that ultimately? So we've done this with a $250 million. This is a $500 million activity. I think it's something that where the university maintains its values, that students will work on things that will pursue their education, that faculty will have an opportunity to pursue really interesting problems in an environment in which they will really understand the deep issues of the problem. I think it's an enormous positive for Berkeley. And I applaud the people who put it together, and I wish it the most tremendous success.
So thank you very much for your nice talk. And I'd like to ask about the two different fate of the Bell Lab. So you used to work in the Bell Lab when they really worked very well, but after you left, now the Bell Lab, the fate face another difficult times. And if you are director of the Bell Lab instead of the director of the LBL, so how did you plan to differently? And then, so can you just briefly mention what was the problem for last 15 years, and then how you can do differently if you're the director of the Bell Lab?
Well, I think what happened for Bell Laboratories was that it changed. The world changed for AT&T. It ceased to be a monopoly. When you were a monopoly, all advances in communications were important to you because you essentially owned the communications business. When you became just one of many competing companies, having basic research that supported business that would be at some other company no longer looked like a good investment. And I think that that ultimately is what unraveled what it is for Bell Labs. I think a similar thing happened at IBM, where IBM was a world monopoly in computing. And when IBM became under very heavy competition, it also looked at very closely at the costs of research and realized that they needed research directed to their immediate business needs. And that long-term needs were no longer they could not capture the value in those investments. That's just the way the world is. I think that places like universities, national labs, are places where we're looking to the long-term values of, or fruits of research. My worry about commoditization of technology is whether the country says, well, should we train people, invest in this field where all the manufacturing is being done and all the jobs are in China. And I think we have yet to face that problem. But that problem is going to come, and it's one that we're going to have to deal with, and I don't have a good answer to it right now. But right now, we have seen a tangible value for federal investment. Analyses have been done to show that you get several dollars back for every dollar that goes into research in businesses. When those businesses are no longer U.S. businesses, it's not clear to me that there will be that kind of investment from the U.S. government. But that remains to be seen, and I think that by changing the way we do business, by being right at the leading edge and working right at the cutting edge, we will be able to sustain the entire enterprise. But there needs to be a strategy, and need to think about it.
Hi, Chuck. I was a little late, so you may have hit on this one before I got here. But I wondered if you wanted to comment on the personal element. You know, the relationships that began as a graduate student through Bell Labs and the like. It's another element of a life and a career. And I just wondered if you wanted to have a minute to say something about
I did talk a little bit about that. I talked about my career, how it is that I got excited about a certain set of problems. I talked about going into a lab that was empty and how that was such a unique opportunity. There are only a few places in the world that you can do that now. And that getting excited about something made all the difference to me. And it was by exposing myself to a lot of different kinds of jobs and opportunities that happened.
So just to expand on, I had in mind things like your relationship with Eric Ippen and Kovic and others at Bell Labs, and how those sustain a relationship over decades.
Well, I think that as you go through your career, you're going to find like-minded individuals that you have tremendous scientific interactions with. I talked about the need to collaborate. For me, they're different kinds of science. I think that if you're the kind of person that likes to work by themselves with a series of students, there are many people who are very successful doing that. If you like working with other colleagues in addition to your students, that's more where I fit, and I found that I have many fruitful scientific collaborations that went over many years. Rich Matthews here at Berkeley, we worked on the rhodopsin kinetic chemistry problem. That's the first step of vision. And I've been really very fortunate. And I think that as you look for places for their opportunities, places where there are terrific people, and during the time I was at Bell Labs, I had marvelously wonderful people. When I left, I was director of a large laboratory, and 4 of my department heads are probably known to you. One was Steve Chu, I think you heard who worked for me at Bell Laboratories. Another was Daniel Shemla, who is here in the physics department. Another was Jeff Bokor, who is here in the EECS department, and is right here. And another was David Miller, who is at Stanford. And so if you happen to be in a place where there's wonderful colleagues and scientists, and one of the things we tried to do at the lab, and Steve Chu is really pursuing this, is that you can take people through interactions with their colleagues, and they go from good scientists to be great scientists. And I think that finding institutions where that's the focus can make an enormous impact in your own science.
So you touched upon the importance of knowing other cultures and of interacting with people from other cultures. And I was wondering if you could just kind of give your insight on different ways that even as graduate students we're able to kind of take advantage of opportunities such as these that would enable us to understand different cultures better.
Well, I think one of the things that, you've got a couple things going for you here at Berkeley. One is if you have a chance to explore different languages, I think that's a wonderful thing. I think that you've got so many people from different parts of the world that make Berkeley such an exciting place to be. Getting to know how people think. Realize that people who've come here have had to adapt themselves to our culture. Having friends and knowing people who've lived in different parts of the world, there's lots to be learned. And so this is a wonderful place to try to tackle that problem. I think that looking at different cultural organizations that are part of the Berkeley campus and seeing what you can learn from that, I think is a worthwhile thing. But it really pays to understand and know how to behave in different parts of the world.
Questions? Actually, I have one. How do you see the role of science, technology, and foreign policy, or how does foreign policy shape science, technology, and vice versa? Or your perspectives on this?
I think I'm beyond my level of competence in having anything brilliant to say about this. I know that there are real challenges in different communities that come about because, intelligence communities that come about because of the loss of American manufacturing expertise. I was talking to someone not too long ago who felt that one of the biggest problems for the Department of Defense is going to have to work more collaboratively and to work in a world in which part of our defense needs are going to have to be made up of technologies that are more advanced in different parts of the world than they are in the United States. And that's a different world. And I don't think it's just the Department of Defense. I think every business is going to have to deal with that. And it's part of the world we're going to live in. It's going to be a richer world in many ways. But we're going to have many friends and many competitors, and we need to deal with that. And I think that's a part of how technology makes a difference. I think that things that like ITAR and export control have had limited success, and we've paid a terrible price. I can give you an example of one. The United States government decided that it did not want any cryptographic capability to be exported. And so the companies that were in the business of producing cryptographic systems said, well, if we're in the United States, we can sell to the United States, but no place in the rest of the world. So they all moved out of the United States. They're in Israel and other places in the world. And so we have none in the United States because they couldn't do business here. Now, with that capability exported, how was that a good decision? And so I think that we don't look at the near term and the long term. And I think that a lot of thought is going to have to go into that.
And any other questions? Well, let's thank Professor Charles Shank again. Sorry.